Today we're doing section 1.6, classifying polygons. First of all, let's talk about identifying polygons. Sorry for that noise. In geometry, a figure that lies in a plane is called a plane figure. So it's a flat figure, it lies in a plane, it's a plane figure. You think about the rug in our classroom. It is a figure that lies in a plane. The plane would be the classroom floor. So it's a plane figure. A polygon is a closed plane figure with the following properties. First of all, it's formed by 3 or more line segments called sides. Number 2, each side intersects exactly 2 sides, one at each endpoint, so that no 2 sides with a common endpoint are collinear. So you don't have any sides that have a common endpoint being collinear. That would be another line. So let's explain with a few more examples. All right, so also continuing on, each endpoint of a side is a vertex of the polygon. An English lesson, the plural of vertex is vertice. Continuing on, we have a polygon can be named by listing. If I find a mistake, you guys don't get credit. Listing the vertices in consecutive order. So, for example, A, B, C, D, E. Let's show you. A, B, C, D, E, and C, D, E, A, B are both correct names for the polygon below. Having pen problems today. So it doesn't matter which vertex I start at, you have to go consecutive. And you don't have to go clockwise, you can go counterclockwise, but you just have to go in consecutive order. And both names would be correct. A polygon can be called convex if no line that contains a side of the polygon contains a point on the interior of the polygon. If I look at this example, which is convex, no line that contains a side of the polygon, this being your polygon, okay, no line that contains a side of the polygon contains a point on the interior of the polygon. I just erased that. Bummer. Not what I meant to do. And if we look here, a polygon that is not convex is called non-convex or concave. So this line contains a side of the polygon. Here is one side of the polygon in black. The line is in red. Okay, this line contains a point on the interior of the polygon. Any of those blue dots are on that line, which are also on the interior of the polygon, and it is called concave. Okay, rewind that and listen to it again if it doesn't make sense, and hopefully it'll get better. First set of examples. Tell whether the figure is a polygon and whether it is convex or concave. The first one, if I look, some segments intersect more than 2 segments. Okay, if you look, some of these segments intersect. If you look at this one right here, color it in red, it intersects here and here, here and here. So it's not a polygon. Here I have, for B, all of my segments just connected a vertex. If I drew a line on any one of these segments, I would not get a point on the interior of the polygon. So yes, it's a polygon, and it is convex. Okay, C. Remember, I need segments. This right here isn't a segment, it's a curve. So it is not a polygon. It would be a very nice ice cream cone, though. D. Remember, I can draw lines on any of these segments. I'll draw a line on any of these segments. And I've gotten a point on the inside of my polygon. So it is a polygon, but it is concave. Okay, go ahead and push pause and write these down, get them in your notes, and I'll move on. I have number of sides. These are all the number of sides of your polygon. 3 sides is a triangle, 9 sides is a nonagon, n sides is an n-gon. Okay, when it gets too big, you just name it. Sorry, let's go back one. The term n-gon, where n is the number of a polygon's sides, can be used to name a polygon. For example, a polygon with 14 sides is a 14-gon. In an equilateral polygon, all sides are congruent. These are a lot of vocabulary words today. In an equiangular polygon, all angles in the interior of the polygon are congruent. A regular polygon is convex, and it is both equilateral and equiangular. So its sides are equal and its interior angles are equal. So let's explain that equiangular and equilateral a little bit further with these 2 examples. Example A, classify the polygon by the number of sides. Count 1, 2, 3, 4, 5, 6 sides. So we would call that, my black ink out, hexagon, because I have 6 sides. All of the segments are equal with these tick marks, so we call that equilateral. And all of the angles are the same by looking at all of these arcs, so we would call that I spelled that wrong. Angular. Okay, this next one has 4 sides, so it is a quadrilateral. Okay, it is not equiangular or equilateral because all 4 sides aren't the same and all 4 angles are the same. And I'm sorry, we've forgotten something over here. I'll write it in red because it's really important. When you have equilateral and equiangular, you can call it regular. Remember, we learned that vocabulary word. Okay, B is not regular because it's not equilateral or equiangular. Tongue twisters. C. Wow, that's crazy. How many sides? Let's see, counting these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if you look at your chart, that is a dodecagon. The sides are all congruent, so it is equilateral. And it isn't convex because if you look at your sides, if I draw line segments over these sides, I would get a point on the interior. So it is not convex. It can't be regular. So we're going to go ahead and call it, whoops, sorry about that, concave. And now I'm blue. Concave. All right, next slide. Sketch an example of a convex heptagon and an example of a concave heptagon. I'm going to push pause and you're going to try these on your own, so I would expect to see these sketches in your notes tomorrow. There are my examples. The first one looks sort of like an altered stop sign. Instead of a flat bottom, I have 2 points, but it's convex. And my second one sort of looks like a fish if you were on the side and you had some bubbles up here. It's concave, and again, my silly things, I always could remember concave because if you looked, you're always going to have a cave. One of the sides would go in, like a cave would go in. Alright, guided practice. Classify the polygons shown at the right by the number of sides. I have 4 sides, so it's a quadrilateral. Explain how you know that the sides of a polygon are congruent and that the angles of the polygon are congruent. The sides are congruent because they're all measuring at 2 meters. Okay, they all have the same length, and the angles are all right angles at 90 degrees. So all the angles are equal, and all of these sides are equal. It's a square. Example 3. Find the side lengths. A table is shaped like a regular hexagon, so all the sides are the same. The expressions shown represent side lengths of the hexagonal table. Find the length of a side. Okay? It's regular, so you know all sides are equal. So you can set them equal to each other. It's like when you know angles are congruent, you can set them equal to each other. Solve for x, minus 3x, minus 3x. X is left over, plus 2, x equals 8. Find the length of a side. If I plug in 8 for one of these equations, let's pick this one. I don't know why. It doesn't matter which one you pick. They're going to be equal. 4 times 8 is 32 minus 2 equals 30 inches. So the length of one side is 30 inches. You try. I have 3 more slides, so you go ahead and try this one. The expressions 8y degrees and 9y minus 15 degrees represent the measure of 2 of the angles in the table of example 3. Find the measure of the angle. I'll give you a clue. It's a regular shape, so all of the sides are equal and all of the angles are equal. So you can set them equal to each other and solve for y. There you go. I solved for y, maybe a little different than you would have. I never like negative variables, so I took the 8y over here and the 15 over there. But that's just how my mind works. Draw a convex hexagon. A hexagon is 6 sides. 1, 2, 3, 4, 5, 6. There you go. This figure shows the tiles on a kitchen floor. What type of polygon are the tiles? Are they regular polygons? What type of polygons? Quadrilaterals. And I don't think it's regular because these appear to be the same, but these appear to be different. And the angles are most definitely different. Maybe these angles are the same, and these angles are the same. So no, it's not regular. This figure is a regular polygon. Find the length of each side. They're regular, so all of the sides are equal. Ooh, an x squared. I can subtract x squared from both sides, and yay, the x squareds are gone. I need to go to a new page. I have 16x equals 32. Let's do x squared plus 6x. 16x equals 32. Now I need my equation. Plug in 2. Sorry. 4 plus 12 equals 16 centimeters. That's it.